Hi class, welcome to your second week of the online class, and today we're actually officially starting the Calc 2 stuff. So if you think in the week 1 it was all about like registering for WebAssign and doing a few review problems, today we're actually going to start learning something completely new. Alright, so we're in chapter 5 and we're going to go to section 5.5, alright, and talk about the substitution rule. Now this class is going to be all about giving you tools in your toolbox to do different types of integrals, and this will be your most important tool. It's like the hammer of integration methods. I think that's a great analogy for it. All right, so here's how it works. Let me set it up with a simple problem, and then we'll talk about it. All right, so obviously because of the fundamental theorem of calculus, all right, it's important to find antiderivatives, all right? But if you think about all the antiderivative formulas that we have, and if you look back to the first lecture online or video lecture I did, I started the PowerPoint with all these different rules. All right, there's no antiderivative formula or rule that tells us how to do this integral right here. Okay, the one that I just highlighted here. All right, so it's the integral of 2x times the square root of 1 plus x squared dx. It's like, I mean, there's a square root in there. There's something underneath the square root. There's 2x on the outside. It's like, how do I even begin to do this problem? All right, well, to find this integral, we have to use a problem-solving strategy of like introducing something extra. All right, we need something new to be able to tackle this problem. Okay, so the something new is we need a new variable. All right, and we change from the variable x to a new variable u, and this is called u substitution method. All right, so that's like the new method we're learning today, the u sub method or the u substitution. All right. All right, so here's how it works. Suppose you let the variable u be the quantity underneath the square root. Like if you look here, all right, if this was, for example, just the square root of x, this would be an incredibly easy problem, because if it was just the square root of x, you would just write that as x to the 1/2 times x. You would get x to the 3/2. It would be like, that's pretty easy. All right. So if I recognize that what's underneath the radical may be complicating things here, all right? So you're going to notice me say a few things. What's underneath the radical or inside the radical, I'm highlighting the words underneath and inside, is the most complicated part. All right, so this is a math tip if you want to write this in your notes as you're watching this. All right, what's inside or underneath is the most complicated part. All right, we let u be the quantity underneath or inside the root sign. All right, so that is, we let u be that value underneath here, 1 plus x squared. All right. Then the differential, you learned about differentials in Calc 1, of u is du is equal to dx dx. All right, but so maybe this part is a little confusing right here. I'm highlighting it. All right, maybe this part's a little confusing. Well, let me show you exactly what we're doing here. I'm letting u be what's underneath the radical. Then I'm basically differentiating u with respect to x. So du dx, well, what is the derivative of this? 1 plus 2x, or excuse me, 1 plus x squared. The derivative is 2x. Well, then all I do is I take this dx and I multiply it across the equal sign, and I get du is equal to 2x dx. Okay? So that was the u part. We made a new variable u. Now the second part of our rule, we need to substitute it in. All right. So formally, without justifying our calculations, let me just show you what we're doing here. All right, and keep this that I've done right here and what I have up here. U is equal to this, and du is equal to 2x dx. I'm going to take my original integral, okay, 2x square root of 1 plus x squared dx. I'm going to move the 2x right next to the dx. Well, look at this, the square root of 1 plus x squared. Well, 1 plus x squared I just defined as u, so it becomes the square root of u. Well, what is 2x dx? Well, 2x dx is the same thing as du. Well, like, look at this. This right here, the integral of the square root of u du, is incredibly easy to integrate. How you would integrate that is with the general power rule. And let me just show you. All right, bear with me while I write this out for you, okay? We're going to integrate this becomes u to the 1/2 du. Well, literally when you integrate that, just the general power rule, right? This becomes u, 1/2 plus 1 is u to the 3/2 over 3/2, which then becomes, flip the bottom, 2/3 u to the 3/2. Just like that, very, very easily. So this simple thing here just becomes 2/3 u to the 3/2 plus c. All right, constant of integration here because it's an indefinite integral. But that's like, great, that's awesome, but what does that mean? Well, the original problem was in terms of x, but now I have it in terms of u. So all I have to do is unsubstitute. So wherever I see a u, just put it back in terms of x. So 2/3 u, well, u is 1 plus x squared to the 3/2 plus c. And that's it. So some crazy integral like this that you couldn't start with, we didn't know how to do, there's no formula for, using this very simple substitution method works out just fine. All right, but maybe we're like, I don't know about that math. That seems a little weird. Is it work? Is it true? All right, we can check our result by differentiating. Now this is just a chain rule. All right, so if you take the derivative of this thing right here, right, you better get this. Otherwise, this method didn't work. Well, if you check your chain rule, if you differentiate what we got, bring the bring the exponent down. So you got this 2/3 out here times 3/2. Leave the inside alone. Subtract 1 from this, you get 1/2. Times the derivative of the inside. Well, the derivative of 1 plus x squared is 2x. Well, if you simplify this whole crazy thing, look what you get. You get what was originally underneath the radical. So this method of u substitution does work out. All right. Hopefully that, oops, sorry about that. Hopefully that wasn't too bad. Let's do another problem. All right. Let's try this one. All right. Sorry for all the jumping around there. Let's find the integral of x cubed times cosine and then in parentheses of x to the 4th plus 2 dx. All right. Let me give you a hint how you can know if you're supposed to use a u substitution. It's like x cubed, and then I've got cosine of this crazy thing. It's like, what do I even do? Notice how this is on the inside, x squared, x to the 4th plus 2 is on the inside of the cosine function. And then on the outside, I have x to the 3rd power. Well, what is the derivative of x to the 4th plus 2? Well, it's 4x cubed. So I have something and something that looks really, really close to its derivative. All right. Well, let's see how we do this. Make the inside, the thing that's making it complicated, equal to u. So make the substitution u is equal to x to the 4th plus 2. When you differentiate it or find its differential, du is equal to 4x cubed dx. Well, check this out. I have an x cubed and a dx, x cubed dx. So apart from that constant factor of 4, it occurs in the integral. So all I have to do is take this 4 and divide it to the other side. So now I have x cubed dx is equal to 1/4 du. So wherever I see x to the 4th plus 2, I can sub in a u. Wherever I see an x cubed, I can substitute in with 1/4 du. So here's what we have. Let me just take the cosine of x to the 4th plus 2. That becomes cosine of u. X cubed dx becomes 1/4 du. Now look at this. It's the integral of cosine of u times 1/4 times du. Well, 1/4 is just a constant, so let me factor it out. So this just becomes the integral of cosine of u du. Well, that's really easy. What's the cosine of u? What is the integral of cosine of u? Well, that's just sine of u. So you get 1/4 sine of u plus c. And then your last step, all right, the final stage. Wherever you see a u, just plug back in our x to the 4th plus 2. You got it. And I bet if you were to take the derivative of this, you would get this. All right, whew. Well, that's just a quick introduction to use substitutions. And the next video I will do some more complicated examples with you guys. All right.